Hi, this is Ranger Scott at Table Rock State Park, and today I'd like to share some aspects about geology. Now, geology can be a hard subject, and you can talk for hours about it, but I just want to give you some basics about some of the things you'll find here dealing with the geology of this area, the South Carolina mountains, and the foothills of the Blue Ridge Mountains. So here at Table Rock and the mountains in South Carolina, the type of rocks that are most prevalent are the metamorphic rocks. Metamorphic rocks are formed when igneous rocks, which are created by volcanic activity and magma, when they are affected by tremendous heat and pressure, it realigns the minerals, it recrystallizes the minerals, and it sort of puts them in a banded pattern. As you can see on this particular rock, the bands coming across there, the alternate types of minerals in these different bands is also called foliation, and you can clearly see that on this particular rock. Now, the two rock types that we have here are granite gneiss. Gneiss is G-N-E-I-S-S, a German word, and amphibolite. Gneiss is the lighter colored rock, and the amphibolite is the darker colored rock. And those are the two main rock types that you find here at Table Rock. Now, the reason our two rock types here are different colors is because of the mineral makeup. Minerals are the building blocks of all rocks, and in our rock types here at the park, we've got real common minerals of feldspar and quartz. They're found in the granite gneiss, and silica's in there too, and that's part of what makes it so light. And on the other hand, the amphibolite, this darker rock, it's pretty black, it has iron in it. The element of iron makes rocks darker, and so you can see the contrast between the two. Here's a sample of quartz that you find in the gneiss often. Has that sparkly quality to it. And again, it's real common in our rocks here at the park. So there you have it, the granite gneiss, much lighter, amphibolite, much darker. I'd like to show you some examples here at the park of evidence of geologic activity that has taken place. One of those things that has taken place deep below the surface is called folding. It's when heat and pressure applied to a rock, which is basically more like silly putty, so it can be bent and is flexible, causes some folding. Let me show you an example of what that's like. If this is my rock and the pressure is applied, you'll see how it buckles and it has that arch to it. That is what happens to some of the rocks. As you see along this bank, you see the severe folding that has happened and still is evident today, that has been pushed up from below the surface of the earth. And you've got that wavy pattern in the rocks, that sharp bend to it. That is folding. One more cool feature I want to show you here at the park with evidence of geologic activity is fracturing. Now, we've mentioned earlier that metamorphic rocks get lined up in a banded sort of pattern with the minerals, and when those rocks get pressure applied and they break, they're weathered or whatever, when they fracture, they tend to follow those banding line, and so you get a lot of straight line fractures. When that happens, you also get fractures perpendicular to those planes of weakness. An example of what happens is you get square looking rocks. You get these right angled corners on rocks. This happens with huge boulders. It happens with small pieces. And you'll see how that takes shape naturally. And so when that happens, you get a lot of straight lines, a lot of flat surfaces, square corners. And when the water drains down this mountain, it follows those fracture patterns. As you see right here, a great example. The water's coming straight at us. It hits a fracture, it makes a right angle turn, it hits another fracture over there and makes another 90-degree turn almost, and that's what you have in this part of the state. Well, thanks for joining me, and the next time you're at Table Rock or in the mountains of South Carolina, keep an eye out for the fascinating geology that exists here.